what we're looking at here is really typical stuff where we another use of calculus to tell us where a function is strictly increasing or decreasing in this case. So what do we want? We want to find the largest interval. So it wants a range of x values or a set of x values or a domain of x values. I don't know if domain is the right word, but we want to find out what x values. The function is strictly decreasing. Now, for a function to be decreasing, what that means is that tangent, so if we've got our function here, any tangent drawn on that function would have to be negative in nature. So as a result, what we'd say is that it will be this function here, this cubic, will be strictly decreasing between those kind of points, roughly. Okay, so let's clean this up and let's see exactly where this function will be strictly decreasing. So I'm going to graph this. So I've got y equals x plus 2. So that means I've got two intercepts at x equals 0 and negative 2. So I can graph that. And I'm doing this so that I get an idea as to what it looks like. So now based on that, I know that it's going to be strictly decreasing here up until that turning point rather. So where's that turning point? We can see that it is negative 1, because it's halfway between those 2 points, but we got to use calculus, we'll differentiate it. So dy dx ends up being 2x plus 2. We let that equal 0. 2x plus 2 equals 0. 2x equals negative 2. That implies that x equals negative 1. So what we say now is that the function is strictly decreasing up until negative 1, because at negative 1 we've got a value of 0. We've got to throw our derivative is 0. So it happens up until negative 1. Where does it start? Well, it goes on all the way from negative infinity. Now, we can never include negative infinity, hence around a bracket. We can't include negative 1 because at negative 1 it has a 0 gradient. And we want to know where it's negative. Where is the function decreasing? And it's decreasing all the way up until, but not including negative 1.